Hi folks, Russ here from Wingtips. If you've ever needed to bend steel wire, you'll know that this can be a problem. I make radio control model aeroplanes and I often have the need to bend steel wire to make undercarriage and other parts for these models. Recently I've needed to bend some wire into some fairly detailed shapes for a set of DIY retracting landing gear for a model Spitfire that I'm making, and I've ended up making a special tool for the job. So I thought it might be useful to you to see how to make a bending tool using some fairly simple tools. A while ago I bought a proprietary tool called a mini wire bender from K&S Precision Metals, and it's pretty good for bending wire up to 1/8 inch thick. But it has a limitation, which is it can't make bends very close to each other. I'll show you what I mean using a piece of 2mm steel wire. This is actually bicycle or motorbike spoke, which is a cheap way of buying a good amount of strong steel wire. I bought a whole load of it, probably about double this amount, probably about 30 pieces for not much money. But the thing about it is it's very, very strong. In this background here, you'll probably be able to see this drill press. This is a recent acquisition, but I'd like to stress that you can make this tool using an ordinary electric hand drill, and you don't need a drill press, and you don't need welding gear. So let me show you the problem. This is the K&S mini wire bender, and the concept is, or the way it works, is that you put this bit in the vise. And this is a really mini little vise, but it's adequate just for the job. Okay, so if I show you a bend with a bit of this wire, you see how it works. So the wire goes in here. It sort of can be trapped under this movable screw, the head of the screw, if you want it trapped, or you can let it float. So that as you make the bend, the wire feeds through, and this can enable you to make a more accurate bend. So let's make a bend in this wire. And what you do is you put the handle on the top, like that, and that's the handle with a little stub sticking out the bottom, and put it on the top, and keeping it pressed down, you bend the wire around like that. So you can put a right angle bend in this quite strong steel wire quite easily, and there it is. Now, what determines the distance you can make the next bend at is the distance between these two posts, this post and this post, and also the thickness of this particular post, which is something like, I think that's probably an M6 or 7 screw. So let's say I wanted to make a bend next to this, some sort of Z bend, Z bend. The nearest I can do and make it is there, because that's the nearest I can get the wire in because of the first bend. So I can make a bend here like this, and again that's easy to do, but that's the bend distance. Now obviously if I'm trying to make a kind of Z bend like this, that distance is far too big, as you can see, I hope. Obviously much too big, twice as big as I want. So what I thought I'd do is make a tool that's similar to this, using the same principles, but with the posts closer together and thinner posts, so that we can get closer with the bend. So if I show you what I made, take this one out, and this is the tool I've made. So as you can see, it's got much thinner posts, These are actually M4 bolts screwed in to a bit of mild steel, and this is a bit of mild steel with an M5 bolt screwed in and chopped off. So I bought these pieces of steel already cut to size from metalsupermarkets.com on the net, and so this is about £5 and this is about £2, so not very expensive. Let me show you how this works and the difference. So if we take the same bit of wire that I was using just now, and let's say I wanted to put another bend in there, so I can now get that close. Hopefully you can see that. So if I put the tool on and bend it around like that, got another right angle bend. Now see how close that bend is. Rather than that distance, we've got that distance. So that's just about adequate for my needs. So that's what I've been able to achieve with this tool, but I'd like to take it one stage further. The distance between these posts here on this tool is 3mm. So I want to take it down to the absolute limit for this wire, which is 2mm wire. I want to take it down to 2mm so that I can get as close a bend as possible, even closer than that. So I thought I'd make it now with you so you can see how I've made it and how you can do this. And I'm a total beginner with metal work, so if I can make it, anyone can make it. But I've picked up 1 or 2 tips on the way, studying videos on YouTube of how to do this and the best practice and how to drill and tap. And so I thought I'd pass this on to you in case you'd like to or need to make a tool like this. As I said, these pins are actually shank bolts and they're just screwed in. So I could take this one out to show you. So that's a bit of a shank bolt lopped off, and this hole is made and tapped using ordinary taps, which again I found some tips on how to do this a bit better than just manually trying to line it up using the drill press. But as I said, you can do it by hand using a hand tool quite easily, and you'd probably get pretty good results. So I'll put this back, and it's not necessary to tighten it up very tight, just so it's in there. These bolts I got on the net pack. These are M5 shank bolts, so they look like that to start with. So when they're in place, I cut them off. I actually use my Dremel tool, but you can quite easily use a hacksaw, a junior hacksaw even, be quite adequate to cut off little bolts like that. So that was one set of bolts. This is the M4 bolts, thinner bolts. These are about like £3 a pack or something. So again, not expensive. So it doesn't cost a lot of money to make this tool. So next I'll show you how I did it with this new piece of mild steel that I got already cut to size. It's a bit bigger than this one, a bit longer, but that's of no consequence. Also, I've made a drawing of all the dimensions of these bits and the hole sizes and the drill sizes and what you need to do, and made that into a PDF, and I'll leave a link to that in the description so that you don't have to reinvent the wheel, as it were, if you want to make something similar. Okay, this is the piece of mild steel that we're going to use. We're going to drill 2 holes in it to take 2 of these shank bolts. We're going to tap the holes so that we can screw these in using the threads already provided, obviously, on these bolts. And then we're going to cut them off and end up with something like this, only this time I'm going to make this distance between these 2 posts 2 millimeters instead of 3. So not a lot of difference, but it should make quite a difference, or a significant difference, to the closeness of the bends we can do. So normally on a piece of material you possibly use a pencil or a gel marker like this with a fine tip to make marks and draw exactly where you want to drill the holes. But I found the experts use a method whereby they paint the surface of the steel with engineer's blue, but you can use a Sharpie like this to get the same effect. And the idea is that you put a coating of paint on, blue or black, and then you can mark where you want the holes by scraping it with something quite finely pointed, like, for example, what I'm going to use, which is this 12-volt tester that I've slightly ground to quite a sharp point using the Dremel, but you can use a file. Incidentally, also, I've taken the rough sharp edges off this block of mild steel, just the sharp edges and the sharp corners, again using the Dremel, but you could use a file quite easily and get the same effect. So let's whack on with it. So first thing I've got to do is paint this surface. So I'm going to use this Sharpie and I'm going to paint it all. I don't need all of it painted, but roughly all of it, just to show you how it looks. So I'm going to put a coat on. Like this. Don't need the edges, but just to make it look neat. And leave that to dry for a minute, and then I'll put another coat on just to make sure we've got enough on there. And then I'm going to scribe a line down the middle and mark exactly where I want the holes drilled. Now, like everything I found in this metal work, although these are M4 bolts, the shanks are not exactly 4 millimeters in diameter. So if we use a caliper like this, we'll see that they're actually 3.84, 3.85, 3.83. So probably nominally, let's say 3.85 for the diameter of these bolts. So if I want to make holes such that there's 2 millimeters between the edges of these bolts, then I'm going to have to drill holes 3.85 plus 2 millimeters, 5.85 apart, and that will give me the centers where I want these posts, so I can drill there, and that should give me 2 millimeters. So want to measure about 5.85, or exactly as near as I can get to 5.85. So we'll have a go at that in a minute. I'm just going to coat this up again, so it's particularly down the middle where I'm going to draw my lines. Okay, so that's like that now. Leave that for a minute to dry, and then we'll get scribing. Okay, I've marked up where I want the holes now. Now hopefully, if I twist that around a bit, you can see. First of all, I've drawn a line down the centre, this piece because the post might as well be in the center. I've made a mark 18 millimeters in from this edge. Now this is a completely arbitrary measurement because all it's necessary is that there's enough metal left around here for the handle to go around here without going over the edge. And with this one, that distance is 15 millimeters, but this block is a little bit longer, so I've made it 18 millimeters, but completely arbitrary really, as long as it's somewhere near there. Now this is the important distance, and that distance is as near as I can get to 5.85 millimeters. I hope you can see there's 2 marks there on that center line. Now I measured that second mark by using the caliper, and I know the experts will say this tends to try and ruin your caliper, but what I've done is just rest the caliper on the edge there, set up 23.85 millimeters on it, put this right on the edge and use this tip to scratch a mark, and that is as near as I can get to where I want those holes drilled. So what I'm going to do next is use my smallest center drill in my drill press to just punch effectively the first bit of the holes, the center of the holes where I want them. I got a little set of center drills for not much money, and this is the smallest one. This is a 4 millimeter, 3.94. I suppose that's meant to be 4 millimeters center drill. It's the smallest one I've got, and I'm going to mount that in this drill press. Now, the drill press, as I said, is a recent acquisition. I'll just move the camera slightly so you can see a bit more of it. This is a Bosch PBD40. I like it a lot since I got it. It's got features that are really useful, like variable speed here without changing belts. It's got a laser which gives you roughly the center of where it's going to drill, a light, a digital rev counter, and a digital gauge to show how much you're drilling into the material, which you can set up. So I like it a lot. Variable speeds, 2-speed gearbox. There's loads of videos on the net about using this drill press. So I'm going to set it up with this marker and just center drill those 2 holes. Okay, I've spot drilled those 2 holes now, and hopefully you can see that. And just by eye with this caliper set to 5.85, hopefully you can see that the centers of those holes are pretty close to that, if not exactly that as measured with the caliper. So I'm happy that I've got the holes in the right place, as near as I can get without more accurate equipment. So next I'm going to use this 3.3 millimeter drill to drill right through the piece, both holes, in preparation for using this M4 tap, which is a spiral point tap. So you can just see that it's a spiral point tap. The difference between this and a normal tap is a spiral point tap is sort of preferred by the professionals because it tends to push the cut material through the hole and out the bottom, rather than a normal tap which cuts the material and tends to leave the chips to start clogging up the tap itself and the threads as the material accumulates in the flutes of the tap. So this is just what I've learned on the net. So I bought this specially, and it was only about 2 or 3 quid to do the job. So it's an M4 0.7 Perhaps you can read that. M4 0.7. Now the M4 is the tap it's going to produce for an M4 bolt. The 0.7 is the distance between the threads. So the rule of thumb for the size of the drill you need for the initial hole is the M4 4 millimeters minus the thread distance 0.7, so that gives us 3.3. That's corroborated by a chart that I've downloaded from the net as being a reasonable holder drill for an M4 tap. So that's what I'm going to do next. I'll set this up in the drill press and we'll see how I'm going to do it. Incidentally, I didn't use any oil on the drill press or the piece, any cutting fluid on these initial holes, because that would tend to wash away the blue, and I didn't want to lose places that I'd marked where I wanted it drilled. But all the future drilling should use cutting fluid. Unfortunately, I haven't got any at the moment. It's on order and I'm waiting for it to come, some Tap Magic from the States. So it's taken a couple of weeks to come. So I'll be using this multi-purpose oil. It's best you can say is it's better than nothing, I guess. It's like 3-in-1 oil. It's certainly better than nothing, but it's not ideal. But it will do for this, because these are not tremendously big holes. So it should be okay for that. The technique is to do little pecks with the drill, not to try and drill it all out in one, to drill a bit, withdraw the drill, let it cool down a bit, put some more oil on, drill a bit more. So that's the technique I'm going to use, again, that I've learned on recently on the net. It seems to work as well. And the other trick I'm going to do is, when I've drilled the holes out, when it comes to the tap, in order to get this tap central, vertical and perfectly aligned, I'm going to use the trick that I've again saw on the net. I'm going to put it in the drill press and line it up with the hole, start the drill press off so it's going about 1500 revs, chop it and bring the drill press down quickly so that the residual spinning of the drill press starts this tap off in the hole. So hopefully I'll be able to demonstrate that to you. But first of all, I'm going to drill the holes. Okay, so I've got this 3.3 millimeter drill centered on my hole. I've got the piece clamped down with the clamp that came with the drill press, which is adequate for the job. I've set the index of the drill so that it's reading 0 when the drill just touches the material. So I'll know absolutely that I've gone through the material when we get above 10. So I'll go through to about 12 and that will be definitely through then. So let's start her off. Okay, we're through that piece now, and so I'll just take it out and clean it off a bit, see what we've got. Okay, so we've got our first hole, looking quite good. Looks in the right place. So just got to get the next one right. Okay, that's how that's looking now. So we've got our 2 holes drilled. The next thing is to do the tapping. Now I want to clean these holes right out completely. Just going to use a bit of WD. It's actually silicone lubricant. So I'm just going to spray that through the holes just to clear them out. So I've done that, and as you can see, that's removing the paint, which we don't need anymore anyway. So there they are, clean inside now. So we can begin the tapping. I've got the tap mounted in the drill now and lined up with the first hole, like so, as best as I can see. And so the trick, as I said, is to start the drill off, get it up to speed spinning, chop the power, and quickly bring the tap down into the material. So let's do that. Okay, now next we want to release the tap whilst keeping it held down in place. And now we can take the tap and the material out of the clamp. And that should be started perfectly straight into our piece. So we can put it in the vise now. So put some oil on. And this is not a terribly good handle, just adequate for the job. But it's the first few turns now that are critical, because we don't want to upset the fact that we've got it straight. So we can test it with this piece. Yeah, still straight there, there. Right, it's biting in nicely now. Just check it with this straight edge. It's okay there. It's okay there. So it looks like it's going in straight. So I'll give it a bit more oil. And we'll keep going. Now, an expert would do this in his sleep, I'm sure, but I want to take it carefully, slowly, make sure we don't screw it up. So that's looking vertical there, that way, and that way. I think we're going all right. Now one of the supposed advantages of the spiral tap is that we don't have to wind it backwards to break the thread, but I still find with this one that is useful. It does feel like it's breaking the thread, breaking the chip, the material that's cut off. So we keep going. So if we're not going straight now, we're probably not going to be, but that's looking quite good. There and there. Yes, I think this is probably as straight as we're going to get. So I found you've got to keep putting the oil on for the best results. And when it tightens up a bit too much, come back and break the chip. Put a bit more oil on and keep going. Not quite through yet. Just beginning to come through, and there's some of the material coming out the bottom. A bit more oil. And we're through. Yeah, nicely through. More material coming out the bottom. So, wind it back. Carefully. And support it when you get near the end or the beginning. And we're out. Let's see how we've done with that. Material away from the bottom. See how bolt goes through that. Okay, going through fine there. So I've cleaned up the holes and put a couple of bolts in. Not quite straight because the heads interfere with each other there, but good enough to see that we've just about got that gap correct for 2mm wire. goes in there with virtually no slack. That's the amount it can be waggled. So precious little sideways slack. And when we get that bolt screwed right in, left hand one, will be, I think, perfect. So interesting to see what sort of bend we can get using that. Okay, so I've chopped off the first bolt, top and bottom. So that's the little stubby one. Now I just got to do the second bolt. The sort of bad news is that the wire doesn't quite go through the gap, but I'll ease that out with a file, and that shouldn't be too much of a problem. And the good news then is that it will be a very, very snug fit, which should be advantageous. So to cut this off, I could use the hacksaw, put this in the vise and start cut it through in situ like this. Or I could use that now as a mark to use my Dremel with this cheapo diamond cutter. So I think I'll do that. So I'll take this bolt out. And hopefully I'll be able to see where I've started that cut. Yep. So I've made up a couple of little blocks of wood to hold the bolt in the vise. So definitely helps to make up these soft jaws. So when that's in there, like that, we can twist it round so we can see where we've made the cut. Yep, just do it up. Doesn't now have to be done up tight because that's rigid and will not move. So let's give it a bit of Dremel. It's going to be a bit loud, but we'll see how that goes. Okay, that's nearly through, but I think I'll finish it off with the hacksaw so that the hot end doesn't drop on the floor. Right, let's see. Ooh, that's a bit warm. Give that a minute to cool down. So it's not too bad. Okay, let's see how it fits. Tighten it up. Almost perfect. There, sits down fine. I think that'll do. So now it's the top bit. So that's 13 mils. We want to mark up. Measure and mark. Okay, that's the mark on 13 mils. I think actually I might hacksaw this because it's clamped quite well in the vise, so it's not difficult to hacksaw, and then we get a more precise cut. The other beauty of these wooden clamps is that they don't harm the thread. Right, so that's in, rigid, strong. See how we go with this. Right, there we are. That's a better cut. And there's the article. So we'll just give it a trim, slight trim on the end. It's not too bad. Slightly beveled it off. So let's see how it looks. Okay, so it's perfect at the bottom. So the tool is made. Problem is, the wire won't go through. So I'll just file that out and we'll give it a test. Okay, a little bit of filing, not much at all. And the wire will now go through and into there. So let's give it a test. This is our test piece before. So if we put this in now, put another bend in. We can see if we've actually improved it. And there it is. So we've actually almost halved the old distance. So that's just perfect. So there we are. The original nearest bend distance, second and third. So I don't think I'm going to need any bends closer than that. So there we go, how to make a wire bender. Don't forget, you can download the engineering drawing for the complete wire bender from the link in the description. Links to all the materials and tools I've used are in the description. I always know where I bought stuff from because I use a piece of software called Wattpot, which automatically keeps track of my purchases. There's a link to Wattpot in the description as well. So thanks for watching, and if this video has been of any use to you, please give it a thumbs up, and I'd really appreciate a comment. I'll be releasing more model engineering videos soon, so why not subscribe? It won't cost you a thing, and you'll get a message when a new video comes out. So cheers for now, and see you next time.